All right, so we're looking at this note sheet right here. Okay, doesn't matter what color you're writing with right now. Tell me something you got from the video about what is a system. What did the guy say? He made a really good reference as to what a system is. Okay, very good. So a system of equations is going to be a set of two equations. I like that you said that they both have two variables. That is true. They're both going to have an x and a y. It's a set of two equations, okay? Or the whole idea, the whole goal, no matter what method we use for solving, it is a set of two equations where what we're doing is we're going to figure out where do they run into each other at. That's it. We're going to find the location of where they run into each other. So it's a set of two equations where you are determining where, okay, and it's going to be on a graph. So the where here is going to be an XY ordered pair. Where you are determining where the XY location of them intersecting. And if you're like, oh, I don't 100% know what intersecting means, it's where they run into each other. It's where they run into each other. So this whole idea is we're going to take those two equations. We're going to figure out where they run into each other. Okay? So how are we going to solve them? Well, a lot of things I teach you one way and we just practice. And I teach you something kind of similar and we practice. This is going to be one topic with three very different methods to solve them. Okay? The first method that I'm going to show you today is graphing. The graphing method. Graphing systems of equations is going to be something you know how to do. We're going to graph y equals lines and see where they run into each other. It's going to be easy. The problem with graphing is that we don't keep graph paper in our back pocket. It's not efficient all the time. Okay, so it's only going to work when there's a nice, pretty blank graph waiting there for you, right? The second method that I'm going to teach you tomorrow and Monday is substitution. And just like in a basketball game or something, when you substitute someone in, we're going to take a part of an equation and substitute it in so that we can solve for a variable. Substitution is probably the longest way of solving, but it's the one that works every time. Okay? Next week on Wednesday, I'm going to give you a test on graphing and substitution. Okay? And so we're going to see if you can know those two methods. And then I hope you're going to be like me. And after graphing and substitution, I'm going to teach you the third method, which you need to understand systems a little more to get, right? But it's the best. You're going to add a step to save you 10 steps on the end, okay? And you're going to do that by eliminating something. So this one's going to be called elimination. And with all of these, our goal is always the same. We're going to do them in different ways, but our goal is always the same. Our goal is going to be to use one equation to get a variable. So essentially taking those equations to get an x, and then once we have the x from those equations, we can plug in the x and get the y. So to use one equation to get the variable, then plug in to get the other variable. Okay. I'll give you a second there. So right here, I'm going to quickly kind of just show you what the end goal of this is going to look like. And then we're going to start on our first method and criteria of graphing, okay? So a system is going to be those two equations written in a bracket. And I'm going to give you a pro tip on how to draw a bracket before you start drawing absolutely crazy squiggly lines. Okay, here's your pro tip. Ready? You turn your paper to the side a little bit. Okay, and you're going to draw it squiggly and then out. Okay, and that's how you draw the bracket. It is not a parenthesis. Okay, it is not a parenthesis. You're going to just do the best you can drawing that squiggly bracket. And then we're going to write the two equations inside of it. So I'm going to use these two right here. I drew my bracket. X plus y equals 2. X minus y equals 4. All right. So this is already done. This equation, this problem right here. If you notice, these two equations have been already turned into y-intercept and were graphed. Okay, here's the big kicker. Ready? Get one of your colors. This right here. This is what we're solving for every time. This is, and it asks right here, what is the coordinates of the point of intersection? The point of intersection is our goal every time. Okay? That's very literal in what it's saying. It is the point of where those lines are intersecting. Okay? So the point of intersection, or what you're going to sometimes read it as, or the solution, is right there. It is literally where those two lines meet. That is the goal, regardless of the way that you're solving, which method, that's the goal. Okay? And so if we look at this graph right here, you should see this is the origin, and it goes to the right, 1, 2, 3, and down 1. So this is the ordered pair, 3, -1. And that would be the answer to my system. Okay? The solution to my this system right here is the ordered pair 3, -1. Okay, and I'm going to show you how to do that with graphing, but we literally took this ordered pair, they graphed those lines, and we found what the answer would be. And just like anything else, this is an x and a y that you could take and put it in these equations and it would work. Okay, so I can say x plus y equals 2. Well, I'd plug in 3 plus -1 and it equals 2. And I could do the same thing on this side and it would equal 4. Okay, so that'd be like you checking your answer. Okay, so take a second. This should be everything we have on the front. And now I'm going to specifically show you graphing. Okay, like I said before, I'm going to use two colors. So if you need to handle that now, but I'm going to show you two colors and how it's done. All right. We are going to flip the page and we're going to be at the front of the next page. I already have it nice and organized for you with 5 dots. My first step of criteria is not going to be math. It is going to be a Jesse Vincent thing because I know the common mistake of these. Okay, so everyone is on the second page. It doesn't matter what you're writing with right now. Okay, but remind me again. I've told you this and you got it from the video. What is the answer to a system? What is the goal again? We have two lines that are going to run into each other. So what is the goal of them? It is where they're intersecting. Your answer is going to be an ordered pair. Your answer is going to be an ordered pair, regardless of the method. So if you get an answer like X is 3, Miss Vincent, that's not an answer, right? An answer would be an X and a Y, 3, 5. That's an answer because the answer is a location of where those lines are running into each other. So right now, we are writing our first step of criteria. I'm not letting you forget that it's an ordered pair. Your first step of criteria is going to be make a goal box with an ordered pair. So quite literally, somewhere to the side, sorry, that got blurry. Make a goal box with an ordered pair. So quite literally, I'm going to make myself my answer box. I'm going to set up an ordered pair in it, and I'm going to write that that's the goal of the whole problem. Because it's going to be very easy for us to get in the steps of solving for x and doing all this, and you're like, oh, I'm done, x is 3. And forget that x, that can't be an answer. X, your answer here is x might be 3, but my y would be 5. And the ordered pair is 3, 5. Do we understand? So first thing we're going to do, we're going to set up an ordered pair as an answer. Okay? Now, we are using the graphing method. So these equations have to be ready to graph for me to figure out if I can solve them. So my first step now, after I set this up, is going to be, are they ready to graph? Well, I spent 2 weeks teaching you how to convert standard form to slope-intercept form, right? So are these equations right here, are they ready to graph? Are they in y equals form? Y equals 1/3 x minus 3. Y equals negative x plus 1. Yeah, they're ready. I can graph those. What's the y? You can see the y-intercepts, and you can see the slopes. If it were 2x plus 5y equals 10, is that ready to graph? No, but you know how to get it there, right? You can bring that negative 2x over and divide by 5, then you'd be ready. So we got to make sure everything's ready to go. It so happens that this one is ready to go, but we still need to make sure it won't always be. So what we're going to say is make all equations in slope-intercept form. In this case, we're ready to go. We have them in slope-intercept form. Okay, so now we're going to do it. You're going to solve a system. I'm about to go back and forth between my 2 colors, okay? I am making this as organized as possible, and I promise you this, the Jessie Vincent way for this is better. So please do it this way, okay? Pick your first color you're going to use. Doesn't matter which one. Pick your first color, okay? And what I'm going to do is color code these equations. I'm going to graph them, and I'm going to ask you one more time. What is the answer to a system? What are we looking for? An ordered pair. So as soon as we find out where they run into each other, that's our goal. I am taking my first color, and I'm going to graph this first equation. So I'm going to write it in my criteria first. I'm going to say graph first equation. Then I'm going to be real Jessie Vincent specific, and I'm going to say in first color. We're going to do this color coded for the whole first week. So I'm using this pink purple color. I'm boxing out this first equation because I know it's going to be in that color. We've already determined that it's in slope-intercept form and ready to go. So you have written graph first equation in first color. You've boxed out that first equation in this color. And now I'm going graph, which is not new to you, right? You know how to graph this. We're starting with the y-intercept. What is the y-intercept? It's -3. Take that color. Ready? We're going to the y-axis. -3. Everyone's right here. -3. And I'm drawing my point. Now we have my starting point. Slope tells me how to move. How am I moving a slope of 1/3? Up 1, right 3. Very nice. Up 1, right 3. Now here's the thing with systems. We're trying to make these lines run into each other, right? So we want them as long as possible so that they can run into each other. So I'm going to say, well, I can go up 1, right 3. I can also go down 1 and left 3. I'm going to turn my paper. I'm going to extend this line. And I have that first equation ready to go. I'm going to put that color down when I'm done. And I'm going to grab my second color. I'm going to ask you for a third time. What is the point of systems? What am I doing here? What am I trying to find? I don't want them necessarily equal to the same thing. But if I'm about to go graph this second line, what do you think is going to happen? I want to find where they run into each other. I want to find where they intersect, right? So I'm going to go write the same process, and hopefully as I'm graphing, I have a point where they run into each other. And then guess what? You're done because that's the answer, right? You found where they intersected. I'm going to write my fourth step of criteria. What do you think I'm going to write?
Graph second equation and second.
Beautiful, Chris Rudy. Graph second equation in second color. I'm going to go draw a box on that equation so I know exactly what color I'm in this equation with. Okay? You ready to graph? When you're ready to graph, I want you to put your pencil on the y-intercept of that line. Good. Good. What is the y-intercept of this line? Positive 1. Very nice. So I'm putting a mark right there. Positive 1. How does this slope move? This is a tricky one.
It moves down.
Very good. This slope is like m equals -1 over 1. So that moves down 1, right 1. So let's do that. From our y-intercept, we're going to go down 1, right 1. Now the goal of this is to intersect, and I haven't ran into it yet, so I'm going to keep going, right? I'm going to go down 1, right 1, down 1, right 1. What happens? I ran into it, right? So I'm going to connect my line. And now I found the point of intersection. I found where they ran into each other, right? If I mark the point, this is where x is 3. Look where I'm going, write it. Excuse me. And y is -2. So that fifth step of criteria is simply going to be determine solution, which is the x and y, from graph. So you can say, in this system of equations right here, and I'm going to draw the bracket, in that system of equations, you made an answer box. You made sure they were both in slope-intercept form. You took your first color and you graphed that first equation, which is something you already know how to do. You changed colors, you graphed the second equation, and you found that they run into each other at 3, -2. These lines, look at this. This is like real talk on this for a second. These lines go to infinity in every direction after this. Here, 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 here. They will never run into each other again. So at the point 3, -2, that's the only place these lines will ever run into each other, right? Because they're going into infinity forever in the next direction. How do you feel about it? It's a lot of little steps, okay? But once you start getting the hang of it, you're going to get it, okay? Here's what I'd like you to do right now. I want to see if you can get one step ahead of me. I'd like you to go to this one right here. This one right here. I'd like to see if you can maybe start that first and second step of criteria, okay? First and second step of criteria.